following is true about f of x based on the graph of y equals f of x below? Well, this is a calculator problem that doesn't require a calculator. All right, so we're just looking at the fact that this graph is of the derivative. Okay, so using this information of the derivative, we should be able to talk about the regular function. Now remember what derivative gives us. Derivative gives us slope. So if the derivative is positive, it's a positive slope, which means it's increasing. If the derivative is negative, that means it's a negative slope, which means it's decreasing. If the derivative is 0, that means it's a maximum or a minimum. And it all depends. So let's look at each of these three options and see what those three options means in those contexts. Option number 1, okay, is asking what's happening between 0, 1, at 0 to 1, and also 3 to 5. It's saying f of x is increasing. Now, if f of x is increasing, that would imply that the derivative is positive, meaning the slope is a positive number. So if I look at this fact, I care about what happens between 0 and 1. So is the derivative positive between 0 and 1? And here's 0, here's 1. Is it above the x-axis? Yep, check. Also, is the same thing happening between 3 and 5? Is my graph above the x-axis between 3 and 5? Here's 3, here's 5, check. 1 is true, 1 is true, 1 is true, check. All right, let's look at the second option. F of x has a local minimum. Now, a local minimum occurs when you go from a negative slope to a positive slope. Why? Because if it goes from negative slope, if it's a local minimum, that means you're going down, and all of a sudden it hits 0, and then you're going up, so you have a minimum. So am I going from negative to positive at 3? Well, here's 3. I am underneath the x-axis, which means, yep, right here it's negative, at 3, and then it becomes positive. So since my f prime of x, is under the x-axis before 3, and then above after 3, that would imply that I have a local minimum. So this is a true statement, which means 2 is also true. Now 3 is talking about concavity. Okay, so what we're going to do is use a second derivative test, which is kind of difficult to look at, but let me explain. Okay, if we have something that's concave down, that means the second derivative is going to be negative. Now, you can find, if you're like, well, this is the graph of the first derivative. I get it. Okay, but at 5, which is here, what we do is we look at the instantaneous rate of change of the slope. So in other words, the slope of the derivative gives us the second derivative. Since the slope of the derivative is negative, since the slope of the derivative is negative, that means the second derivative is less than 0. So this is also a true statement. Okay, so all three of these ended up being a true statement, which means the answer is D. So calculator problem, no calculator needed. Fun stuff. Happy times.